Yes, today we will do the disadvantages of the law of octave. First one, it was applicable. It was applicable only up to calcium. That means lighter elements were applicable, heavier elements were not. Then during those time, only 56 elements were known, and there was no place for the new elements discovered in the Newland's law of octave. Then discovery of noble gases weren't there. So these all were some of the drawbacks of Newland's law of octave. And coming back to the Mendeleev's achievements, it was told yesterday, all these things. And the disadvantage also we had studied. Limitations like position of hydrogen should be placed along with the metal or non-metals. And then isotopes did not find a place in the periodic table. And then I told you dissimilar levels of place and all these become some of the drawbacks. The new elements which are discovered is like it was mentioned, Eka aluminum, right? So these, some of Eka boron, Eka silicon respectively, because Eka aluminum has properties similar to that of aluminum, silicon that of similar to that of, so therefore it was understood it that way. Now these all, as I told you, you may get a question based on this. Give a brief account of earlier classification of elements. You need to mention about all the three. Understood it? Very simple question. Or maybe advantage of Mendeleev's periodic table or disadvantage of Mendeleev and etc. So simple question. You read that NCERT book completely. All right. Next, we will be doing about the modern periodic table. Modern periodic table. In 1913, Henry Moseley was a scientist, chemist, who said the properties of elements are based on the number of electrons, that is atomic number. So he said atomic number of an element is more fundamental property than its atomic mass. Like earlier, as I told you yesterday, most of these elements were classified earlier on account of atomic mass because scientists were going only about the atomic mass. It was said atom is heavier or lighter, nothing beyond that. Now, after a number of years, it was proved that the atoms are divided into electrons. Remember the Dalton's atomic theory. Atoms are considered as indivisible, indestructible particles. Now, later onwards, it was said that atoms can be divided into electrons, protons, and neutrons. So, Moseley was a scientist who said that the properties of elements are more dependent on atomic number rather than atomic mass. So he adopted atomic number as a basis of modern periodic table. So therefore, the periodic law which Mendeleev proposed was changed into modern periodic law. Modern periodic law says that the physical and chemical properties of elements are periodic functions of their atomic numbers. So Henry Moseley was the one who said the properties of elements are not depending on atomic mass, it is depending on atomic number. Now we know that how do we classify the element as a metal or a non-metal? We look for the valence electrons. We say if the valence electrons are less than 4, what we used to say that it has a tendency to lose electrons, so it will be a metal. And if the valence electrons are more than 4, we say it has a tendency to gain electron, therefore it becomes electronegative, therefore it can be a non-metal. Understood it? So this is one question. What was the basis of earlier classification of elements? Atomic mass. And what was the basis of modern classification? Atomic number. And if they are state Mendeleev's periodic law, you need to write down the physical and chemical properties are a periodic functions of their atomic mass. And physical and chemical properties of elements are a periodic functions of their atomic number. That is become the modern periodic law. Understood the differences? The basic difference between modern and earlier classification is that of atomic mass and atomic number. Earlier classifications all were based on atomic mass and the modern one is based on atomic number. Clear? Now, In modern periodic table, also consists of the horizontal columns called as periods and the vertical columns called as groups. Same as that of Mendeleev did. In Mendeleev's classification, we had the horizontal columns termed as periods and the vertical columns termed as groups. So in modern periodic table also contain horizontal columns as periods and the vertical columns as groups. Understood it? In modern periodic table, all the anomalies of Mendeleev's periodic table got removed. There are some disadvantages of Mendeleev's periodic table, right? And all those anomalies which were in Mendeleev's periodic table got removed when, because in Mendeleev's periodic table it was based on atomic mass. Now, once atomic mass is changed to atomic number, all isotopes, what are isotopes? Atoms of the same element having different atomic mass, same element and same atomic number. Now, we are shifted the classification into atomic number, that means that problem is solved. Understood it? Ascending or descending order of their atomic mass, when it has come down to the atomic number, that problem is also solved. Argon's atomic number is 18, potassium is 19. So potassium comes after 19, atomic number, that problem is solved. So all these problems are solved. Understood it clearly? In modern periodic table consists of 18 vertical columns called groups and 7 horizontal columns known as periods. In modern periodic table, it was having 18 vertical columns, we call them as groups, and 7 horizontal columns as periods. All right. Now what we are going to do, the properties of these groups and periods. This is important. Some of the properties will be asked in examination. The first thing is I am going to take a particular period. These are our horizontal columns, right? So lithium, beryllium, boron, carbon, hydrogen, oxygen, fluorine, and neon. Atomic numbers of these elements are 3, 4, 5, 6, 7, 8, 9, 10. Electronic configuration, this is 2, 1, this is 2, 2, this is 2, 3, and this is 2, 4, nitrogen is 2, 5, oxygen is 2, 6, fluorine is 2, 7, and this is 2, 8. Now something similar from left to right we can see. What we are studying? The horizontal columns are the left to right columns. Moving from left to right, they are the periods. So this is what we say, it is the second period. Why second period? Each of these elements is having 2 cells, 2, 1, 2, 2, 2, 3, etc. goes on. So first property belongs, write down, the period number is equal to the number of cells. The period number is equal to number of cells. So this is the second period. Every element has got 2 cells, therefore it belongs to the second period. Now let's take the case of hydrogen. Hydrogen's atomic number is 1, its electronic configuration is 1, therefore hydrogen belongs to the first period. Let's take the case of aluminum. Electronic atomic number 13, electronic configuration 283. It has got 3 cells, so aluminum belongs to the third period. So period number is equal to number of cells. Understood it? So if you know the atomic number of that element, we can understand in which period that element belongs. It can be easily understood. 7 horizontal columns, 7 periods. Right? Now the next property, first one is the period number is equal to the number of cells. And the next one, this is valence electron is 1, 2, 3, 4. The electronic configuration, we are studied in 9th standard. The valence electron cannot be more than 8. Remember? The valence electron cannot be more than 8. So what we can be say? The number of valence electron increases by 1 from left to right. 1, 2, 3, 4, 5, etc. The first property, period number is equal to number of cells. And the second one, the valence electron increases by 1 up to 8. Isn't it? This has got 1 valence electron. This is having 2, 3, 4, 5, 6, 7, 8. So moving from left to right, the valence electron increases by 1 up to 8. So what is the first property? Period number is equal to number of shells. The second one, valence electron. What are valence electrons? Electrons present in the outermost shell. So the outermost shell has got one electron in the first element, the second one is 2. So what can we say? Valence electron increases by 1 up to 8. Alright? The next one, valency. Lithium has a valency 1, beryllium has a valency 2, boron has a valency 3, carbon has a valency 4, whereas nitrogen has a valency 3, oxygen has 2, this is 1 and this is 0. So what can we say? The valency increases by 1 up to 4. Isn't it? Lithium is 1, this is 2, this is 3, and carbon dioxide it is 4, and the nitrogen's valence is 3. So what can we say? The valency increases by 1 up to 4 and then decreases. And what is the definition of valency? Don't just say that it is the number of valence electron. And what is the meaning of valence electron? The electrons present in the outermost shell, that are the valence electron. So if the valency is defined as number of electrons a neutral atom gains or loses to become stable configuration. Number of electrons a neutral atom loses or gains. Now you can understand, it will lose 1 electron to get the stable configuration, it will lose 2, it will lose 3, and it will share. And at this case, what has happened? It cannot lose 5. Over the second what I used earlier, an atom has to lose electron, it requires energy. And so much amount of energy is not available, then it will not lose. So nitrogen has a tendency to gain 3, oxygen 2, fluorine 1, and it does not gain, either lose an electron. So valency is defined as number of electrons a neutral atom loses or gains to become stable. So valency increases by 1 up to 4 and then decreases. Understood it? Valence electron increases by 1 up to 8. Number of shell present is the period number. Clear? The next one, metallic character. Lithium is a metal, beryllium is metal, boron is metalloid, carbon is non-metal, nitrogen. So what has happened? Left to right, the metallic character decreases. And if the metallic character is getting decreased, in left to right, non-metallic character increases. Now you must understand what is the definition of metallic character. Metallic character is defined as ability of an atom to lose electron. Understood it? Lithium can lose only 1 electron, which is it can lose it easily. This is 2 with little difficult, 3 more difficult, and carbon does not lose, and this one. So ability of an atom to form electropositive ion. Electropositive nature is also known as metallic nature. Understood it? So going from left to right in a period, the ability of an atom to lose electron keep on decreases. And that means metallic character decreases. And why the ability decreases? Because remember, as I told you earlier, if an atom has to lose electron, it needs energy. Lithium will lose 1, less energy is needed. Beryllium has to lose, more energy is needed. Boron has to lose, still much more energy is needed. So as we go from left to right, the energy availability is becoming lesser and lesser and lesser. That means sufficient energy is not available. The atom is not going to lose the electron, and in that situation, it is going to become metal. So left to right, the metallic character decreases. And similarly, the non-metallic character increases. What has happened? When we move from left to right, ability of the atom to gain electron increases. Isn't it? This will gain, this can require, this requires only 3 electron, which it can get it easily. Then this requires 2, this requires 1. Understood it? So ability of an atom to gain electron increases from left to right, and that means the non-metallic character increases. The metallic character decreases. Now, metallic character is also known as electropositive character. So what has happened? When the metallic character is decreased, electropositive character decreases. Non-metallic character increases, that means electronegative character increases. The split properties. Ability of an atom to lose electron will decrease from left to right. It keep on continuously loses because more and more energy is required to lose. The one which loses electron much easily is most metallic, and one which does not lose any electron is most non-metallic. That way it is going. So metallic character decreases, non-metallic character increases. Understood? Electropositive character decreases, electronegative character increases. Understood? The next one, size of atom. This is inert gases is in this classification we have placed, so the properties are not included in that. Inert gases, can we say they are as metals or non-metals? Metals are those elements which have the tendency to lose electron. Non-metals are the tendency to gain. And what about inert gases? They neither lose nor gain any electron. So chemically we cannot classify them as metal or non-metal, but on account of the physical characteristics, inert gases are classified as non-metals because they all are gases, bad conductors of electricity, etc., etc. Therefore, they are taken as non-metals only on account of physical characteristics. Based on the chemical characteristics, we cannot classify them. You understood it? Metals are those elements which have the tendency to lose electron. Non-metals are the tendency to gain. And inert gases, neither it loses nor it gains. Therefore, what can we say? We cannot classify them as metal or non. So, leaving out that, inert gases, the size of atom decreases. The moving from left to right, the size of atom decrease. And why should the size is getting decreased? Every element has only two cells. Each element is having only two cells. Now, let's take the case of lithium. It has got 3 positive charge, it needs to attract 2 cells. And when we talk about fluorine, it has got 9 positive charge, that also needs to attract 2 cells. Understood? Therefore, what can we say? Moving from left to right in a period, the number of cells remain the same, no doubt, whereas the nuclear charge keep on increasing. Moving from left to right in a period, number of cells remain the same, whereas the nuclear charge increases. And when the nuclear charge is increased, the force of attraction towards the electron increases. So naturally what happens? These 3 protons attract one shell, that is the second shell, and 9 protons attract the second shell. So it is so clear that 9 protons will be exerting much larger force than that of the 3 protons. Am I right? Therefore, what is likely to take place? This second shell, the second shell of fluorine, the electrons are more attracted towards the nucleus. So they will be approaching nearer to the nucleus. By which what has happened? The size gets decreased. So we can say that size of atom gets decreased from first to the 17 group. Means first till the second last. We cannot say that the neon size will be smaller than that of fluorine or larger than that of fluorine. We can say that the size of neon is larger than that of fluorine. Now, I explain that also. When we take the case of neon, it has got both the 10 protons. First cell contains 2 and the second cell contains 8 electrons. And if there are 8 electrons, the orbit is full. When the orbit is full, between the electrons, the distance becomes less. And when the electrons are at shorter distance, force of repulsion is more. And because we have studied it, the force is inversely proportional to the square of the distance. So when the distance between the electrons are less, the force of repulsion is more. And when the force of repulsion is more, what happens? The electrons will be pushing outwards. See it? So the nuclear force of attraction decreases. Moving from left to right, the force of attraction exerted by the nucleus is getting increased. But the last element, that is the last element where the orbit is full, and since the orbit gets full, the distance between the electrons are being very less. So therefore, what has happened? The electrons are, due to the repulsion, electrons are pushed outwards. So that makes its size larger than that of the previous one. So we can say that the size of neon will be larger than that of fluorine. We cannot compare that with oxygen. It may be less than, smaller than that of oxygen or larger than that of fluorine. But we can say that the inert gases will be having its size larger than its previous size. Understood? So size of atom decreases up to the second last element. The reason I told you, in all the cases the orbits are not full, except in inert gases where the orbit is full. And because since the orbit is full, the force of repulsion overcomes the force of attraction exerted by the nucleus, which will push the electrons outwards, therefore its size becomes larger. Understood clearly? So size of atom decreases from left to right. Now one question is, how does the oxide nature of elements vary how does the oxide nature of elements vary in a period? Now simply you can understand it. Left to right, metallic character decreases. First chapter we have studied metallic oxides are known as basic oxides and non-metallic oxides are known as acidic oxide. So how does the nature of oxide vary in a period? The basic nature of oxide decreases. Have you understood it? Metallic oxides are basic oxides and non-metallic oxides are acidic oxide. So when the metallic oxide's nature is getting decreased, that means the basic nature of oxide decreases and acidic nature of oxide increases. Understood it? So don't say that oxide increases or decreases. You know that oxides are of three oxides: neutral oxides, acidic oxide, basic oxide. So moving from left to right in a period, the basic nature of oxide decreases and the acidic nature of oxide increases. Understood it? Or metallic oxide, you know that metallic character decreases. So metallic oxide character decreases, don't write that. Oxides are of acidic oxide or basic oxide. So basic nature of oxide decreases, acidic oxide nature of increases. These are some of the properties. Enhanced one by now. Ionization energy. Ionization energy. It is a minimum energy needed to remove. Ionization energy is defined as it is a minimum energy needed to remove an electron from an isolated gaseous atom. Minimum energy needed to remove an electron from an isolated gaseous atom is known as ionization energy. So symbol, the ionization energy of metals are less because they need less energy. Metals are electropositive, they have the tendency. So they have the minimum energy needed to remove the electron. Understood it? So ionization energy of metals are very less and ionization energy of non-metals are more. So what happens? Moving from left to right in a period, ionization energy increases. Ionization energy increases. Have you understood it clearly? So these are some of the properties of elements in a period. The rest of the properties of elements in a group, we'll be taking it in our next class.